Good afternoon, and here we have a symmetrical phase supply with an unbalanced load, and here the load is connected in a star. So determine the line currents flowing here. Line currents and the power supplied to the unbalanced star collected load in the three-phase circuit. So first thing we have to do, we have to calculate the currents, and if we have time we calculate. These neutrals are not connected, so we have to calculate the voltage, the load voltage at phase 3, phase 1, phase 2 and phase 3. Okay, and later we calculate the voltage between these two neutral points. Okay, and then we calculate the power consumed by the three phases, the load, three phases, it means the three loads. It means, let's call it S1 prime, S2 prime and S3 prime, and the total power absorbed by the load. And here we calculate the power produced by the three generators, S1, S2, S3, and the total S. So we go step by step. First step is to calculate these first, the currents and the voltages, and later in second film I think we will calculate the powers. Okay, let's write our equations. We have two mesh here, two meshes, and we can write the first equation, and here we have a load. So the first equation we can write that the line voltage U12 is equal to the drop at this impedance minus the drop at this impedance. The second mesh, we can say that U23 is equal to Z2 I2 minus Z3 I3. The third equation, we can say that the three currents, the sum of the three currents is 0, so it means that we can say that I1 plus I2 plus I3 is equal 0. We have a system of three equations, a linear system of equations with three unknowns, and we try to solve it by the determinant method. So it means the first thing to do is to calculate the line voltages. If V1 is equal to V0 degrees, V2 is equal to V is equal to 200 phase voltage minus 120 degrees, V3 is equal to V plus 120 or minus 240. So the line currents, geometrically, we can see that this is u2, 3, this is u1, 2, this is u2, 3, and this u3, 1, and we can see without calculating, of course we can calculate by writing this. This is u12 and u23 is v2 minus v3, and we can give the result because geometrically we can see that this module is square root of 3 times v, the phase voltage, and the argument we see that it's 30 degrees, and this one is square root of 3v minus 90 because there is an angle argument of minus 90 degrees. So we can write now the three equations and try to solve them. So we can write, we said that this one is 380, 30 degrees is equal to, these we can write them in polar form, it's better. It's 32, 31, argument is 21.8, and here the module is 46.1, argument is minus 12.53, and here is 52.2, and argument is minus 16.7 degrees. Okay, we can write these equations now. Here it's 329.1 plus j 190, and this is u12 and u23 is equal to 380 minus 90 degrees, it means it's minus 380, and this is equal to 30 plus j12 times I1 minus 45 minus j10 I2, and this one is equal to, you can write it here, 45 minus j10 I2 minus 50 minus j15 I3, and we have the last equation is I1 plus I2 plus I3 is equal to 0. So we can write the in this form. Okay, now we can replace all this and we obtain the system of linear equations, and the solution we do it by determinants. So it means that I will write again these equations again in another form. We can replace one of the variables, I1 we can write it as minus I2 minus I3, and the equations we obtain becomes like this: 380 30 degrees will be equal to minus 75 plus j2 I2, because we replace I1 by this, and minus 30 plus j12 I3, and here we have 380 minus 90 is equal to 45 minus J10 I2 minus 50 minus J15 I3. And we can now use the determinant method. It means we can calculate I2 by calculate the main determinant, which is the main determinant is here. We can write it 75 plus J2. Here we have 45 minus J10, and here we have minus 30 plus J12, and here we have minus 50 minus J15, and in the numerator we will replace this by this, so it means 380 30 degrees, and here 380 minus 90 degrees, and here we have these two, and the result I will give you now plus J12 and minus 50 plus minus J15. So it means I2 will be equal to this times this minus this over this times this minus this, and the result will be, I will give you the result here, I2 will be equal, I will write it, I2 will be equal to 4.09 minus 124.22. Now I3, we have the same denominator, but we have to change only, we have to change, okay, we have to change these. This is the same, this one, we will leave this one here, because we are calculating I3 now. We'll leave 45 here, minus J10, and here we will take the two that are here, 380, 30 degrees, and 380 minus 90 degrees. So the result of I3 is this times this minus this times this over this times this minus this times this. So the result will be I3 is equal to 4. I3 is 5.475, and the argument is 135.42 degrees. And I1 we can calculate from this equation, and it will give us I1 6.22, and the argument is minus 4.22 degrees. So we calculated the currents. We can now calculate the voltages. Because it's very easy. Once we have the currents, the voltages are easy to calculate. So we wrote the impedances in polar form because it's convenient for calculating the voltages. So V1 n prime is Z1 times I1, V2n prime is equal to Z2 times I2, and V3n prime is equal to Z3 times I3, and by n prime is equal at Vn minus Vn prime, or let's call it V1n minus V1n prime. Let's calculate this, and this is Z1 is 32.31 times argument 21 times 0.8 times I1, which we have calculated here, 6 to 2 argument minus 4.22. Here Z2 is equal to 46.1 argument minus 12.53 times I2, which is equal to 4.09 argument minus 124.22, and here Z3 is equal to 52.2 minus 16.7 times I3, which is equal to 5.475, 135.42. Okay, so the result is, we can write it here, V1n prime, this times this will give 201.03, argument this plus this will give us 17.58 degrees. V2n prime is equal to this times this will give us 188.73, and the argument is minus 136.75 degrees, and V3n prime is equal to 52.2 times 5, and this is 285.79, argument 118.72 degrees. Now we can calculate Vn prime, which is equal to Vn minus Vn prime 1. Here is 220 minus what we calculated here, and it's 17.58 cosine times 201.03. It's minus 191.64, and the imaginary part is plus j, 17.58 sine times 201.03 is equal to 60.72, and we can write now 220 minus 191.64, it's 28.36 plus j, 60.72, and in polar form this is squared plus 60.72 squared equals inverse